Are we live already? Looks like we're live. Hello everyone and welcome to yet another recreational programming session. So let's make a little bit of an announcement and officially start the stream. So let me quickly do that. Red circle live on Twitch. Oh my god, so it's a little bit uncomfortable for me. And what are we doing today on Twitch? Let me see, let me copy paste the title. Today we're programming in C in 2022, by the way. Imagine programming in C in 2022 instead of Rust. Unimaginable, am I right? So twitch.tv/Tsoding, or whatever is the language of the month today. I'm pretty sure Rust is already outdated and everyone has to program in Carbon. I don't know, like I don't follow these monthly trends of languages, like I just write software instead. All right, so let's actually ping everyone who wants to be pinged, and here we go. So what we're going to be doing today, we're going to continue developing Olive.c, which is the graphical library that we studied some time ago. So it's a very simple graphical library that doesn't really use any third-party dependencies, and what it does is essentially renders everything into the memory, right? It renders pixel by pixel into the memory, and then you can take that memory and do whatever you want with it. You can save it as a file, you can render it using OpenGL, for instance, you can put it into a texture, or you can maybe render it using you know, HTML5 canvas if you compile that library down to WebAssembly, right? So it's very versatile. It's compatible with anything because it does input-output through just chunk of memory, right? It doesn't really care. So that's the beauty of this library, and I developed it for myself for like quick prototyping, quick debug rendering, if that makes any sense, because quite often I want to just like quickly debug something visually and just put something on the screen, and I don't want to set up like very complicated libraries. I'd rather have something small that just renders pixels into the memory, and that's basically how this library was born. So alrighty, so let me go ahead and just start developing this thing. So you can find a link in the description if you're watching on YouTube. If you're in the chat, you can find it in the chat, do the project command, you know, the usual thing. So today specifically we're gonna probably start with developing alpha blending, right? So we don't really handle the alpha channel of the pixels at all. Right, we do have an alpha channel, but it's just basically ignored, or it's rather just copied. When you say just fill rectangle, I can actually show you. Let's take a look at the library. Right, so fill rect. If you just try to fill a certain rectangle, right, with a certain color. So as you can see, we use 32-bit pixels, and that means we have 4 bytes. 1 byte for red channel, 1 byte for green channel, 1 byte for blue channel, and 1 of course for alpha. So right now we don't handle alpha at all. We just, like, as you can see, we just assign it to the pixels, and that's it, right? But what we're supposed to do is actually blend them together, like, right? So we have the color that is currently in the pixel, and we're trying to assign the color in here, and we have to blend them together according to their alpha, according to their transparency. So according to their opacity or transparency, whatever you want to call it, right? So it's actually two opposite things, right? Transparency and opacity are opposite. Hello everyone. So yeah, so alpha blending should not be very complicated, so I think we're gonna implement it maybe within like half of an hour, maybe less, and then we're gonna continue with other topics. Luckily we have plenty of them. All right, so are you guys ready? Are you guys ready for some epic alpha blending? I don't see poggers in the chat. Where are the poggers in the chat? I didn't see the poggers in the chat. Anyway, so let me see what we can do. So maybe I'm gonna start with the test, right? So because we have a testing framework where I can do shit, right? So here I'm testing you know, fill rect, fill circle, draw a line, fill triangle, nothing particularly special. And one of the things I probably want to do, I want to do something like test alpha blending, right? Test alpha blending. So I don't remember if the test cases are supposed to actually accept anything. As you can see, they do not accept anything. So that means I can just go ahead and start doing stuff, right? So I'm gonna start with actually filling up the background, right? So I'm gonna just do pixels, width and height. So this is a width and height, and I think I have a variable. It's not a variable, it's a constant for the background color. Alright, so let me maybe draw some sort of a rectangle, right? So let's just do fill rect. So then we're gonna pass the canvas, and we have to pass something, right? So maybe we're gonna start with the top left corner at 0, 0. And we're probably gonna go... I kind of want to have two overlapping rectangles, if you know what I mean, that like have like 50% of alpha. So, and since I want to overlap them, maybe I want to actually have like a third of the width and third of the height, right? Multiplied by 3 divided by 4, and here multiplied by 3 divided by 4. And what's going to be the color? Let's actually use the red color, because why not, right? There we go. So this is a simple test. I'm going to build everything, right? So it doesn't really work because we are rendering into actual pixels, right? Okay, so we have a global array of actual pixels, right? So an actual pixels is what's actually rendered by the library. We also have expected pixels, which are loaded from the test case file, right? So that's basically the terminology of this testing framework that I came up with, right? You have an actual pixels, you have expected pixels, you compare them together. If they match, everything's fine, right? So that's the terminology. Junior Frutas, I hope I pronounced your name correctly. I'm sorry if I did not, right? So I'm really sorry. Thank you so much for 2 months of Twitch Prime subscription. Thank you, thank you, thank you, and welcome to Epic Olive.c Club. I hope I pronounced Olive.c correctly. I remember Kolumbetka said that my C is too soft, so I'm trying to make it less soft, even though it has a soft sign at the end of it, but I don't know, I don't speak Ukrainian. Hey, where did you get that ACM t-shirt? I won it in a fair fight, in a fair fist fight, with a better programmer than me. He was maybe a better programmer than me, but he was weaker physically, so that means I deserve this t-shirt and he does not. Is alpha blending done in linear color or in non-linear? We're gonna do it in constant. All right. So let's actually see what we're gonna test here. Like what is it going to render, right? So we built the test cases, I mean the testing framework, and now we're gonna try to run it, and it's supposed to fail. Well, it didn't fail, which is nice. And this is because we didn't even add our our test case into the list of test cases, right? So we have to define test case. We're going to put it in here, and when it tries to run that test, it should miserably fail, right? So let me see. Bin test. Okay, so as you can see, it miserably failed. So it says it could not read that specific file. Test alpha blending expected, right? So, and this is where expected pixels are located, right? Consider running this thing to create it. So since we created the function, we never actually generated the test case itself, right? So let's go ahead and just like say record, and as you can see, this thing was generated, right? So what it does, it just like runs the library, right? And whatever is the behavior of the library is basically becomes the expected behavior, and the next time if you modify something, it's going to be tested against the previous behavior, right? So that's basically what we're doing here. So it's a very simple testing framework. Okay, so let's take a look at the alpha blending. So as you can see, it's kind of difficult to see, but here is the whole image, right? So the background is light gray, and this is the red square that we draw that goes three how to say that, like if you take like 3/4, right? So if you split the size of the entire command, this is 4, it's actually 3/4, right? Is that how we say it? I think this is how we say it. And the reason why I want to do that is because I want to have the same size rectangle, but actually snapped to the right bottom corner, so they overlap. And once we implement alpha blending, that overlap is going to be actually visible, right? Because like the second rectangle is going to be semi-transparent. So let me actually see. So let's draw the second rectangle. By the way, what's cool? The fill rect supports negative width and height. It does in fact support negative width and height. So I hope I didn't miss any subscriptions. Okay, so essentially what you do when you want to fill a rect, you provide the top left corner and provide width, right? So this is going to be width, and then you provide height, and the library essentially renders you the rectangle based on these two things, like the position of the corner and the size. But what's interesting is that you can actually provide negative width and height, and this left top corner becomes right bottom one. So here's the position, and then you have negative height and negative width, right? And it will just render it like that. It actually handles all of that, right? So it doesn't care if it's negative or non-negative, it's just going to handle everything correctly, exactly as you would expect it, right? So, and essentially I want you to render the second rectangle snap to the right bottom border, so which means that I can actually do it like this. Right, I can say that this is the corner, and then I can take the size of the previous rectangle, but take it as negative, right? And I'm gonna use the green color in here, and that should work. So that's precisely why I implemented that feature, because I wanted to make it convenient for myself. In fact, this is a little bit out of the bounds, so you probably want to do something like -1 in here, right? So something like this. Okay, so let's do, actually, let's keep recording, build.sh, and there you go. So it should also generate all of that stuff, and let's find this thing in here. And there you go, we have two overlapping rectangles, but one of them is not semi-transparent. One of them is not semi-transparent, and this is because we don't really use the semi-transparent color at all. Right, so we're using green color, and if we take a look at the green color in here, so the alpha channel FF in here is actually full, so it's not supposed to be semi-transparent, right? So let's do the following thing. I'm gonna actually put like AA in here, indicating that it's gonna be semi-transparent, right? So let's actually run it one more time. One more time. And if I auto-revert this thing, surprisingly, it became more gray. Which is... Oh, it's not sus, actually. It actually became... Yeah, okay. So, it became a little bit more dimmed. And the reason why it became a little bit more dimmed is because even though we're not handling alpha, we're using STB to save that image. And STB does handle alpha. So that's why it became semi-transparent. So this entire thing is by itself semi-transparent, but it actually overwritten the red color. So that's why we cannot see the red color, you know, behind the green one. So that's basically what happened. So everything's fine, yeah. So now we need to actually handle all of that, right? So now we have to actually handle all of that. Let's actually go ahead and implement that. So the first thing I probably want to do is to have some function, Olive.c mix colors, right, that will accept two colors and mix them together, right? Unit 32, so this is the first one, unit 32 TB, and it should return this one. There you go. So it would be kind of nice to maybe split all the components of the colors, right, into their corresponding values or something like that. So let me see. So you know what? I think I'm gonna call them C1 and C2. And you know why? Because I want to have their separate components like RGBA, right? 1, 1, 1, 1, and this one is going to be 1, 2, boom. Can your Veeam do that? I'm sorry if it was too loud. So because it actually generated like a really high sound because it snapped, so I hope it wasn't too loud. Way too dank. All right. All right, so essentially what we need to do, I need to actually do something like that, right? A boom uint8 underscore t and a boom, right? Boy. So R in here, right? R in here is supposed to be something like 0xff. Then C1 if we shift it 1 byte to the right. So essentially I'm gonna put some sort of a reminder for myself. So the components are located like this. So this is alpha, this is blue, this is green, this is red, right? So but because this is the little engine machine, they're gonna be located in the memory as XRR, XGG, XGGBB, AA, right? So the literal itself is going to be spelled like this, but because of the little endianness in the memory, it's going to look like that. So that's basically the reason why I, write it in the opposite order. All of that endianness actually kind of like screws up with your brain all the time. So yeah, you have to always keep that in mind, bruv. It would be also kind of cool to have like a function that decomposes the colors into its components, but I can't return 4 values. Or can I? Maybe I can do something like unpack color, where I accept the color, and then I have the components, right? But I accept the components as the array. Right, I'm gonna say that, yeah, the array has to be 4. Of course, the compiler doesn't check that, but I don't really care. It's more for the documentation. Right, it's more for the documentation, and then maybe you can have some sort of like, component red, which is gonna be, it actually depends. So maybe it's gonna be 0, then green. Maybe, by the way, it's not unpack color. Let's actually specify unpack RGBA32, right? Because we're unpacking a specific format, right? And also, I want to do something like this: component index, right? And a component index is basically the index of the corresponding component, right? So that should be fine. So the reason why I want to do that as an array is because it will make it easier for me to do that in a loop, so to speak, right? So we're going to do something like size t 0 less than 4, so that's the amount of components. You know what's interesting is that we can do something like count comps, and we can even use that as a magic value everywhere now, because we know that it's going to be equal to 4, right? That is freaking epic, dude. That is freaking epic. All right, so, and the way we're going to do that is basically comp I equal to, C, 0xff, right? So we take one single component and then we shift that component by 1 byte. There you go. As you can see, we're programming in Haskell now. We're binding the monad. C is the monad, right? Everyone thought that C is the language, but it's actually monad. All right. So let me actually see. And the reason why I did all of that is because now I can do something like this, right? So comp 1, right? So this is going to be count comps, and this is going to be the second one. And now instead of doing all of that hardcode bullshit, I can do unpack RGBA32 C1 comp 1, right? And in here I'm going to do query replace 1 2, boom. There you go. So now I can actually quite easily access, for example, red component, right? Comp red of the first color, or comp alpha of the first color, and so on and so forth. As you can see, it's pretty goddamn convenient. Holy shit. Holy fucking shit, mate. Holy fucking shit. So, and how are we going to be approaching all of that? So the question is how we compose together the alphas of those colors, right? So how do we compose together the alphas of those colors? That's a very interesting question. So I think I'm not gonna care about this thing right now. So I'm only gonna mix together the other components based on the alpha, right? So for instance, we take the red component, then we take the red component of the second color, and we mix them together according to the alpha. So if it's 0, it's supposed to be closer to this one, right? If it's 1, it's supposed to be closer to this one. So effectively what we have a lerp, right? So we're lerping from one color to another one by that specific alpha. But lerping makes sense if we are using alpha, if we have alpha from 0 to 1. In fact, all the components in here, they have a range from 0 to 155. So we have to work with that somehow. Right, we have to work with that somehow, and the question is how. So how do you usually implement lerp? Right, so you have, let's put that in the comment. Components are this instead of this, which makes it a bit complicated, right? So it makes it a bit complicated. Lerp is usually implemented like so. So this is the comment. So we take the distance between A and B and we multiply it by t. Since it's from 0 to 1, we basically just like scale the distance from 0 to its full distance, right? And then we shift it back to A. So this is how usually lerp is implemented, but t has to be from 0 to 1. So let's go ahead and maybe substitute A and B with these things. So to turn this alpha into 0 to 1, we have to divide it by 255, right? So if the range was from 0 to 255, by dividing it by 255, we'll get it to 0 to 1, so that should be fine. And let's go ahead and replace everything. So here we're supposed to have that, then according to that specific formula, right? According to that specific formula, we have something like this. Multiplied by this entire thing. There you go. So that's what we got. And now the question is, can we simplify that so we don't really need any floating point stuff, right? Because the range from 0 to 1 is a floating point stuff, and we want to kind of get rid of that because our library doesn't deal with floating points, right? So what we can do here, we can actually expand the parentheses. We can basically distribute this entire thing among the components of the sum, right? So something like this. And what do we have? What do we have? So this is red multiplied by alpha, which also means that we can first multiply these two things, right? So we have component red, then component red the second one, and then multiplied by alpha, and only then divided by 255. And in here, right, and in here, we can also rearrange things like that, and as you can see here, we divide by 255, right? So we divide by 255, which means that we can actually put it back into here, right? And that is actually a very, very good way of doing that, I think. So the components are too big, kind of don't like that. I would rather prefer to just have something like R1 and here something like R2 and here A1, right? It would be way more readable, if you know what I mean. Would be way more readable, which also means that I can do it like that, right? You can just multiply it like this. Yeah, so if you just do that in that specific order, it will simply work. It will simply work. So what I'm thinking is that since I'm sort of like blending together these components, maybe it makes sense to actually move that into a separate function, if you know what I mean. Right, so uint 8, let's mix comps, right, and in here we actually take sort of two components, right? And doesn't really matter which one in here, right? So maybe this one is going to be C1, C2, and this one is the alpha, right? And we're going to actually mix all of that according to the alpha. Right, this one is C1, C2, C1, this is the alpha, right? And that should be fine. That should be fine. Okay, so how are we going to implement all this? We can just straight up uncomment it and put it like that, but this is the problem. And the problem is this product is actually going to be maybe potentially bigger than the 8 bits, right? It might be potentially bigger than 8 bits, which means that maybe it makes sense to accept them as 16 things, right? So essentially when I'm gonna call them in here, they're gonna be automatically expanded, right? And once we divide it by 255, it's gonna be sort of like put back and truncated yet again. Yeah, sounds like a good idea. Why not? Why the hell not? Okay, so now let's go ahead and just iterate through the components, right? From 0 to count comps. And the question is how we're going to be organizing all of that. So this is going to be plus plus I, and we have to do Olive.c mix comps. So we'll have to take comp 1 I, comp 2 I, and we'll have to use specifically comp 2 component alpha, right? Which will automatically also mix together alphas, but maybe that's exactly what we want, right? And then maybe I'm gonna assign it back to component 1, right? And after that, maybe we want to pack the components back. So we mixed everything together, we want to pack it back. So we have something like unpack, maybe we should create pack. Return pack RGBA 32, and we're going to just provide components 1. There we go. Now, so we're going to do pack. Pack RGBA. So this one has to return unity, and this one. All right. Interestingly enough, we'll have to do that in the opposite order. We have to do that in the opposite order. Right, because first comes the red, green, blue, and alpha, right? So, and we have to put them sort of like AA, BB, GG, RR, right? So that's what we have to do. So that means, what can be the best way to do that? Right, if we take the components, so first let's create a result, which is going to be 0, right? So this is the result, this is 0, and maybe I'm going to just take the component 1, I, and shift that component by this amount of bytes. Yeah, I think that makes sense. That makes a lot of sense, right? And then I'm gonna like combine it with the result, and then I'm gonna return the result. I think that's the best way to do that, at least for now, right? So, and semicolon, of course. And do we need to have anything else? So the thing here is that we also compose alphas by the second alpha. And I'm not really sure if that's a correct way to do that. So this implies that we mix the alphas by the alpha of C2. I'm not sure if this is a correct way to do that, but what is the correct way to do that? I don't really know what is the correct way to do that. So I'm gonna just put that node in here and just continue. Because I've already done this kind of mixing of colors before, where I mix the components by the alpha of the second component, including the alphas of the colors. And it worked fine, right? So maybe there are some pitfalls with this approach, but I don't know, like I don't see anything super obvious, you know what I mean? Right, maybe there is a better way to do that, maybe there are some arguments on how to better do that, like I don't really know. Right, I'm just gonna leave it as it is and just move on. All right, so that's basically everything I wanted to do, right? And let's go ahead and just try to compile this into a thing and see where it fails. So, okay, this one has to be enumeration, nothing particularly special. So this is not a single, the first component, we only have one. Passing argument 2 from incompatible pointer, right? Why is that an incompatible pointer? Are you sure about that? Oh yeah, this is because it has to be 8, right? It has to be specifically 8. There you go. Do we have anything else? Okay, so it seems to be compiling. And let's actually try to record whatever we have, and let's take a look at the generated image. Is the generated image semi-transparent? I'm not actually sure. I think it failed a little bit, right? So alpha blending, and we can't see shite in this mist, so it didn't work. So it didn't work. Let's actually find out why. Why exactly it didn't work? It just oh, okay, I see. Because we never use this function. Right. That's why. That makes a lot of sense, not gonna lie. Right, so because right now when I call fill rect, right, when I call fill rect, we just assign the color. I implemented the function, it compiled and stuff, but well, I mean, you have to call it somehow, right? So how are we going to be combining? We're going to combine this color with this color, like so. And we're going to be assigning it back to that original color. So that's basically what we're going to do. So maybe because of that, it makes sense to make this function accept the second color by a pointer, so you don't have to do this weird expression, but yeah, it is what it is. Let's go ahead and recompile everything we have in here. All right, and try to record it one more time, right? And let's take a look at the alpha blending, and do you see this shite, chat? Do you see this shite? Do you freaking see that? If this doesn't look like a semi-transparent rectangle, I don't know what it looks like. So it actually is semi-transparent. How about that? So, and we implemented all of that without any floating points, entirely in integers. So we can actually make something like maybe we can make it even more transparent, if you know what I mean, right? So let's make it even more transparent. Interestingly, by the way, so the alpha of the first color, is 255. The alpha of the second color is, let's say, half. And we are combining them together. Ending up with alpha that is halfway through, right? I mean, like half. Let's put it this way: 1 and half. We ended up with alpha that is halfway through from this thing to this thing, which I don't think is particularly correct. You know what I'm thinking? I think that we should always use the alpha of the first color. So the first color has the notion of sort of like the canvas, the one that we put things onto, right? And we should probably preserve its alpha. Yeah, I think I came up, yeah, through the logic and reasoning, I think I actually came up with the correct, more or less correct for our situation way to do that. Right, so essentially, maybe we should not, yeah, we should not just like use alpha. Maybe we can even do something like comp alpha, right, which will effectively not include the alpha, right, so everything that is less than alpha, and effectively it will not include that. So, and I'm gonna just remove that, and it will keep the alpha of the component first. Okay. All right. So let me actually rebuild everything and re-record everything right away. So, and let's take a look. So it should be fine. There we go. So the thing I want you to do, I want you to make it even more transparent. So where is alpha blending? So let's actually make it 5.5. Boom. Blending, and I need to revert this buffer, and it's even more transparent. How about that? Isn't that epic? I think it's pretty epic. I think we need to add another one, or maybe we should add some other shapes like circle. Does it mean that in final image we have alpha which was applied 2 times? I excluded alpha computation just now. One time from by rendering and one time by STB. Actually, maybe the thing I said about STB handling alpha is incorrect. I think it's not STB handling the alpha. I think STB literally just saves whatever alpha you gave to it to the file, and that is it. I think it's Emacs that handles the alpha, right? And it handles the alpha during the rendering on the screen, right? So I'm sorry, I was incorrect actually. When I said that STB handled it, I think now if when I think about it, I think STB doesn't really handle it. It's Emacs when it displays the image. By the way, this image is displayed by Emacs, right? So if the final image has some alpha, the viewer that you use to view that image is probably going to handle that alpha somehow. What the hell is STB? STB is a header-only libraries that do different things. Right. Let me actually give it to you. STB. So here it is. So specifically, like, it has a lot of libraries for different topics. For instance, it has a library for handling fonts, or for handling sounds, or for handling images. Specifically, we use 2 libraries from STB to load images and to save images, right? And the one that we use to save images is called STB image write. And this is literally a single file. So it's under 2,000 of lines of code. It's actually very small for the library, and this is the entire library. Like, literally, this is the entire library. It doesn't depend on anything except Olive.c, right? And it's capable of saving images in PNG, BMP, TGA, HDR, JPEG, and it's just support them. It's a very small library, like a single header-only library, and it just allows you to generate images in these formats. So that's what they are. But I mean, again, as I already said, images is not the only things that STB project has libraries for, right? Was it developed for embed system? It was developed for anything, really. I mean, maybe in 2022 embed system actually depend on standard C library, but I don't know. The thing about embedded systems is that whatever program you developed in embedded system, it probably will work anywhere, right? You can probably easily port it to work anywhere. Right. I mean, at least the universal code doesn't depend on anything like hardware specific. Hi, love your videos. Thank you. I'm really glad that you love them. I always wondered what education you have. Did you go to college, university, or you self-taught? Why do you ask it like it's somehow two mutually exclusive things? So one of the reasons why modern education doesn't work is because people think that if you got a higher education, you automatically doesn't have to be self-taught. These two things are not mutually exclusive. In fact, you have to do both. You have to do both. And what kind of education I have? I have a pretty crappy education, so yeah. I like to think that I don't have an education at all. But I mean, formally, I have some sort of education, but I have a diploma that is probably today not going to be accepted as a diploma at all because of political reasons. But again, it shouldn't freaking matter. It shouldn't freaking matter, right? What matters is that what you know, what you actually know, not what a paper says you know. Paper doesn't do shit. You do the shit. Come on. I mean, it's important for like networking and some other social bullshit, but I am a social person, right? So all that social bullshit is actually very alien for me. Anyway, let's continue. So I wanted to actually add more things to the test case, right? Let's add some circles, shall we? Fill circle. So this is actual pixels, and let's draw a circle somewhere at the center, right? So half of the width and half of the height. And what we're gonna use, I think I'm gonna use the color blue, right? So this is gonna be A 2020. And let's see what this mother flipper is going to generate for us. It's not gonna generate shit, bro. Because you're supposed to provide the radius, right? So what's gonna be the radius? Let's say that the radius is going to be maybe half of the width, because why not? Why not? Half of the width, half of the width. Okay, so let me see, let me revert this entire thing, and there we go. It's a circle, right? But it's too big. Let's say that I want to have. Actually, let's do outer revert. I think outer revert is pretty epic shite. Where is that outer revert? And I'm gonna do boom. There you go. And it's now we have a smaller circle. Maybe, I'm not sure. It's kind of difficult to see that this is like orange or something, but maybe that's fine. That's fine. I'm gonna keep it like that. And as you can see, it's not semi-transparent. And this is because we don't really handle semi-transparency in the fill circle, right? So fill circle. So again, here we're just slapping the color onto the canvas, and this is not how you mix the colors. You're not supposed to slap it, you're supposed to mix it. Careful. Just blend it. Okay. And let's try to recompile this entire thing, and boom. Now the shite is semi-transparent. I think I would say it's too transparent. Let's make it less transparent. Something about like, I don't know, BB. Why not? Should be less transparent now. What is going on? I don't understand. Are you gonna refresh or what? Come on. All right, so it's less semi-transparent. Isn't it cool? Isn't it cool? I think it's pretty freaking cool. So, and the last thing we need to add here is probably triangle, right? So let's go ahead and render the triangle somewhere at the center. And that triangle is going to be semi-transparent as well. So here we're just testing transparency. So we also have some lines and stuff like that. All of that should have semi-transparency. To be fair, just when you start doing blending, I think your program may become slower, right? Which could be a concern if you don't need blending. Here's an interesting thing. I think I just realized why color blending is disabled in OpenGL by default. I think I just like came to the same conclusion myself. Just by implementing the graphics library. Maybe it makes sense to actually don't blend the colors by default. Right, maybe it makes sense to just like make it optional, but to be fair, we don't have a way to sort of like configure the library, if you know what I mean. Right, so we don't have a way to configure it and say, okay, don't blend these things or blend those things. Or I would even say maybe it's not a really concern, right? So because the purpose of this library is not to be fast, right? If I wanted to be fast, I would use GPU or something like that, but we're doing completely CPU. So the performance is not particularly the goal of this library. The goal of this library is high portability and simplicity, right? So, and also convenience. So that's what's important here. And this library is already extremely portable, right? So as you can see, it can generate, you can use it to generate PNG images. The library itself doesn't generate PNG images, but you can use the library to then generate PNG images. You can compile this entire thing to WebAssembly. You can compile it to WebAssembly and then just render animations with that library, and this is something that we developed in the previous stream, right? So I can actually show you Python 3, HTTP server 69 as 69, right? So I'm gonna go in here. So as you can see, this is a rotating triangle, and that rotating triangle is rendered using our library that is compiled to WebAssembly, right? So that is compiled to WebAssembly, and then we load that library using JavaScript, right? And we just hook up rendering into HTML5 canvas, right? And what's interesting is that, by the way, the cool thing I did off screen, I took that example, like literally that example, and ported that to SDL, right? Bin triangle. So this is SDL version of the same example, a native version. So the same piece of code, the same library works natively in SDL and also in, you know, in WebAssembly with HTML5 canvas. So it's like the level of portability, that thing, right? So that's basically the goal of that library. And it's actually pretty cool the way I did that, right? So I have a triangle. So here's the universal part that does the rotating and stuff like that. And then behind the if-def, I have SDL platform that implements the event loop and stuff like that. So when I compile that for SDL, I enable SDL platform, which makes this executable. And when I compile for WebAssembly, this entire code will be cut off, and only the thing that responsible for the logic and rendering into the memory is going to be compiled. And then I'm going to take that WebAssembly module and hook up that memory into the HTML canvas. So yeah, so this is example of random rotating triangle. The idea is that you can take this code and compile it to different platforms with different random mechanisms, native with SDL, WebAssembly, HTML5 canvas, and there you go. So that's basically the goal of this library. So it's a very simple library to do very simple things. Did you code this from scratch or did you use any boilerplates? Depends on what you mean by boilerplate. I don't know. I mean, how much copy-pasted code constitutes boilerplate, right? So for instance, if I include stdioh, right? Okay, I wrote this line of code from scratch. I'm super proud of myself. I wrote that line of code from scratch. Then I need to include another library and boom, I copy pasted. Oh my God, I plagiarized myself. I should not be proud of myself. Like, how much code constitutes boilerplate to the point that I shouldn't be proud of the work I've done? Like, where is that threshold? One more character, if I copy paste one more character, is that boilerplate? Like, I don't understand. What's the definition? Right. What are the criteria? So it's kind of difficult to define, in my opinion. It's kind of difficult to define. It's all blurry. I guess it doesn't matter. Yes, you're on the right track, my friend. You are on the right track. Saying the right things. Okay, so what I wanted to do, I wanted to actually blend the triangle, right? So we learned how to blend rectangles, we learned how to blend circles. The time has come to blend the triangles. Let's draw a triangle, my friends. All right, so let's go test.c. And I want to actually copy paste the triangle, you know what I mean? Let's just copy paste the triangle. Fill triangle. So, as you can see here, we have to provide a canvas. So the actual canvas is located somewhere here. Right, it is located somewhere here. And the question is, where we're gonna put that that triangle? Maybe I'm gonna just like put it on the whole canvas. Why not? Right. So we're gonna use 0 height. So it's a left bottom corner is going to be one leg of the triangle, right? Then width height is going to be the right leg of the triangle, something like this. And then the head, the pointy head, is going to be maybe in the middle, which means that we're going to have something like width half, and in terms of height, it's going to be 0. Right. So the color that we're going to use, I think we're going to use, we already used the red color, we already used all of these colors. Let's use like a yellow color or something. So does anyone remember what's the yellow color? I think it's a red and green. Right, so it's going to be AA, and this is going to be 20. There you go. There you go. So this is what we've got. Chat, what second programming language do you recommend to learn after JS? HTML, because JS is kind of useless if you don't know HTML. All right. I think HTML complements really well JavaScript. I would even say that they're created for each other. They were created for each other. They go together like cookies and milk, let's say. HTML and JavaScript. All right. So let's go ahead and just like render this into, I think. And there you go. So alpha, and here is the triangle, but we can't see shit behind that triangle. And you know why? Because it's not semi-transparent, even though we said that it's supposed to be semi-transparent, right? So it has the transparency of BB, but it's still not transparent enough, and this is because we're not handling that stuff in the library, right? So let me go here and just like do the mixing as usual. Let's do the mixing. We have to do that in 2 places at least, right? So I can't see shite in this mist. Okay. So this is the second one. Wait. This is draw line. I guess it's useful for line as well. Why not? Alright. I kind of don't plan to test line because I don't know, I'm too lazy. I'm gonna be testing only the triangles and stuff like that. So let me do it like this. So pixels width. Are you sure? It just uses width. Like I call it pixels width in all of the functions except the triangles where I just call it width. What the hell is that? I think for the sake of consistency, we have to agree that all of these things should be called like pixels width. Right. That's what we should agree upon. Pixels width, pixels. And do we have anything else? All right, so let's actually go ahead and try to recompile this thing. Another one. Another one, just following the compilation errors. That's the beauty of statically typed languages. You just follow the compilation. And there we go. So here is the semi-transparency. So all of these shapes are visible through each other, which is kind of cool, isn't it? I think it's pretty freaking cool, right? All of them are semi-transparent and we are actually testing all that. So it would be kind of cool if we could see that in animation. Right. What if we extend our triangle example to actually add a bouncing circle that is semi-transparent? All right. So let's maybe commit whatever we have. Chat, I think the time has come. The time has come to commit whatever we've done. So I'm gonna just run the test to confirm that everything passes, right? And let's do a committee. So before I do committee, I need to remove the to do about alpha plenty. All right, so let's do committee. Implement alpha blending. So let's try to do the following thing, right? So here we have a rotating triangle. So let's add another moving thingy. You know, maybe the usual thing where the thing bounces off, but this time it's going to be semi-transparent. Right, let's make it semi-transparent and see if it actually works or not. I think it's going to be interesting. Right, so let's go ahead and do that. What do you think? So let's go to examples and let's go to triangle. So the cool thing is that I'm going to be modifying only the universal code. That means it should work automatically in SDL and web version as well. Right. So let's go ahead and do that. So here we have the angle. So maybe I'm going to call it triangle angle to actually, you know, specify what exactly we mean in here. And we're going to have like a circle, right? Bouncing off circle. Circle. I'm going to use the integer coordinates, I think. Circle X. And initially, let's actually put it somewhere at the center. Right. So, and this is going to be height, half of the height. There we go. And we probably need the circle radius. Circle radius. There we go. So what's going to be? Let's say it's going to be 100. Also, maybe I want to make the circle color, right? And the circle color, of course, the circle is going to be semi-transparent. And let's make it blue. Thank you, Emacs. Very cool. Right. So this is basically the things we're going to have. All right. When I render everything, so here I render the triangle. I'm not really sure why I put separate scope in here, maybe because I copy pasted this thing from somewhere, but anyway. So this is going to be triangle. So this is a triangle. And here we're going to have the circle, right? So this is the circle. And let's go ahead and just do Olive.c fill circle. And we're going to have circle X, circle Y, and then the radius. Circle radius. Circle. How do you spell it? Circle color. There we go. So for now, I don't think I'm going to be updating this circle at all, right? So let's just keep it as it is. Let's try to compile this entire thing and see how it goes. Right. Okay, so there is a little bit of compilation error, which is fine. So this is a triangle angle. So we'll probably use triangle angle in like at least 2 places. Triangle angle. Okay, and after that, I'm gonna do triangle, and here is the circle, right? So since it stays at the center, it's not clear that it's like semi-transparent or anything like that, right? So we need to start moving it. What's interesting is that a render acts like both a rendering and updating function because it accepts the delta time. Delta time is the amount of time between the frames, right? So, and maybe because of that, we can like put this thing in here. So this chunk of code simultaneously updates the state of the triangle and renders that triangle. And here we're gonna also simultaneously update the state of the circle and render the circle, right? So as you can see, we have like sort of components in here, right? Separate components. And maybe we can even put them in separate functions as well, because why not? All right, so how are we going to be updating the circle? So we need the circle dx and dt, right? Circle dx, So it's probably going to be something like 1 and circle dt, dy, not dt. So, okay, this is rather interesting. So we also need some sort of like a speed of the circle. Right, I can do something like maybe 100 and 100. There you go. And here what we're supposed to do, we're supposed to do circle x. Well, the usual thing I do, right, the usual thing I do is that I create sort of like a next x, circle x plus circle dx, but we also have to take into account the delta time, right, we also have to take into account the delta time. So what's interesting is that delta time is float, which is probably fine, right? Anyway, so if x is less than 0 or x is greater or equal to the width of the screen, we essentially don't want to go there. So this is the next state of the circle x. This is the next x. If that next x goes out of bounds, we don't really want to use that x. We want to discard it, and we actually want to reflect the angle. So what we want to do, we want to do dx multiplied by -1. That's what we want to do. If it's not out of bounds, we want to use that new x as the current x, right? So that's essentially the logic in here. That's basically the physics. All right, and we want to repeat that for y as well. So we can replace x with y, and there we go. So now we do that for y as well, which actually implies a very cool thing. So, for example, one component can be reflected, another one may not necessarily be reflected. So as you can see, we handle collision by the components separately, right? So that should work. Okay, so let's give it a try. Let me try to recompile this entire thing. So I have to go here. So build.sh, and I'm gonna do beam triangle, and as you can see, this thing is moving and it goes out of bounds, and something is completely freaking wrong, which is rather weird. Oh, I think I know what the hell is going on. But as you can see, transparency is working. So the problem here is that we don't take into account the radii, right? So essentially here, what we have to do, we probably have to subtract the radius, right? So maybe circle radius. So if it's less than 0. And then here, maybe we have to add the circle radius. And the same goes here, minus circle radius. Come on. Plus circle radius. There we go. So do we do anything else? I actually doubt. Maybe it has to be also a bit faster. Right, so we're going to simultaneously build everything and run everything. So it's a bit too slow. I wonder why. Okay, so for the left and right, it's fine. Okay, for y, something is wrong with y. I see what's wrong with y. It doesn't use height. It doesn't use proper height. All right, so that actually... Okay, as you can see, it is actually moving like that. Isn't that cool? It's actually a bit slower, but I mean... Yeah. And all of that, by the way, without OpenGL. Yeah, that's a good point. All that without any OpenGL. We can maybe make it even more semi-transparent. Let's actually do 99. Alright, so yeah, that's cool. That is actually cool. So this is alpha that was coded manually, by the way. Let's go ahead and see WebAssembly version. So this is WebAssembly version, by the way. So it also works in the browser, right? So rendering pixel by pixel works in the browser as well. So everything works, everything twerks, I would even say. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. Man, I really wanted like develop something like some serious, more or less serious graphical application without OpenGL. Right. How can it work in the browser? We compile this thing to WebAssembly. That's how it works in the browser, because we compile it to WebAssembly. And since this library renders into a memory, right, it renders into WebAssembly memory, and then we take that WebAssembly memory and we interpret it as pixels. I can even show you. So if we open the JavaScript code, right, so this is the index.js, right, so we organize the loop, right, through request animation frame and stuff like that, right. We call the render function, which, you know, renders everything, and it returns the pointer in memory. So if you take a look at the original function of the triangle, so the render function accepts the delta time and returns the pointer. It returns the pointer, and it returns the pointer to the memory into which we're rendering everything in RGB A32 format, right? So in the JavaScript, we call that function, providing the delta time and stuff like that. We get that pointer, then we take the WebAssembly memory. That's the thing you can do. Like, this is JavaScript, right? This is JavaScript. I take the WebAssembly memory, I get the image from the memory by that pointer and interpret it as image data. Right, you can have the clumped uint8 array, and you can say, okay, interpret this as RGB A32-bit image, and then you can take that image and you can put it into the HTML5 canvas, and I do that 60 frames per second in JavaScript. So this is how it works. This is what we've done, right? And yeah. So that's how it works in the browser. Nothing particularly special. And again, it doesn't really use any third-party dependencies in the browser as well. This is vanilla JavaScript. It doesn't even use any build step. It doesn't use NPM. It doesn't use Webpack. It doesn't use all of that Zoomer bullshit. It's just like a single JavaScript file that loads up the WebAssembly module that we compiled from the C code, and it just like sets up some math libraries. Like, all of that is manual, and it's just like very simple. And it's like 47 lines of code, right? So you're not using STB image functions here. No, like, I'm only using STB image functions for loading and saving PNGs. In here, I do not load, neither I save PNGs. Like, why do I need STB here? Right? So I'm just generating image, I'm generating graphics, and I'm instantly displaying it. I don't need to save it anywhere. I just don't need to save it. That's why I don't need STB. Can you please make the circle same color as background and no transparency? I want to see it make cool holes in the spinny track. Sure. All right. So what's the background color? What do we use as a background color? So fill. Oh, I don't even have this as a background color. Background color. Okay, let's go ahead and just put that like so. Background color, and okay, background color. Okay. Are you happy? Are you happy? I'm bringing before devs, but I'm planning now how to start and where. I studied in secondary school, but it didn't fascinate me that time. In fact, my first experience with like programming, more or less, with Turtle graphics, if you know what I mean. Turtle graphics. If you never heard what it is, it's just like something that is used for teaching programming. Right. So my first more or less like actual experience with programming was Turtle graphics when I was, I think like 10 or something like that. Like we had a computer in the school, right? Computer class. I didn't have computer at home, but we had it in school at class. And I tried to do Turtle graphics, and holy shit, it sucks. I didn't like it at all. It was boring. I couldn't understand shit. And I was not interested in programming until it became like 16, like 6 years later. So it's totally fine. if you first like do programming and you don't find it interesting at first and you find it interesting later. So okay, enough minute metal. I turned 27 and getting more and more into programming, wondering, isn't it too late to start? What does it mean to be too late? I don't quite understand. Like, people say, isn't it too late to learn programming, or isn't it too late to do that and that and that? What does it mean? I just don't understand that question. Okay, so imagine like you have an appointment to doctor, right? And you're late. So the word late is applicable to this situation. What does it mean? That means you don't have an appointment right now. So you schedule another one, right? So the word late is applicable to this context. What does it mean to be late to learn programming? Like, I don't understand. What are the, let's say, repercussions if you're too late, right? I don't understand. Is the programming police gonna go after you and put it in jail? You're started learning programming too late. You're not legally allowed. What does it mean? I just don't understand. People keep asking these questions. I don't understand it. Right. So, who's gonna punish you for starting at 60? Why? Like, I just don't understand. Like, it's just like, what? You wanna do shit? Just do that. Don't ask anyone. Like, don't let anyone to tell you when and how to do what. Just do things. Like, I just don't understand. It's late if you want a PhD in CS and win Turing Award, maybe. Dude, in what age Alan Turing, started programming? I'm pretty sure. Well, I mean, I actually started programming earlier than Alan Turing himself. How about that? Well, that dude had to invent programming to start programming, but I mean, still. Well, I mean, you can technically say that he was doing programming way before that, because mathematicians were experimenting with Turing complete systems way before computers existed, right? You can say that that was programming as well, right? So, but I mean, come on. It's just like, all of these definitions are like superficial. You want to do something, just fucking do that. Don't ask anyone, don't let anyone to tell you what to do. It's just like, come on. Did he win the Turing Award though? By the way, has anyone awarded Turing with the Turing Award? And has Nobel ever won a Nobel Prize? These are important questions, actually. Never heard about that. Oh, he was pardoned by the Queen. Nice award. Oops, sorry for being homophobes. Like, when did they actually issue the pardon? Like, decades, like half of a century later. Nice award. Anyway. So, what are we doing? What are we doing? So I think this feature is over, right? So we implemented alpha blending. How about that? How about that?